Okay.
Yes, I started
Other tables, I think.
Yeah, put it on.
Stephanie?
Hello, everyone. We can get started. There are a couple more people
Oh, thank you.
coming in. And then I have it. Okay, cool. Thank you. Okay, my name is Anis. I am a PM here at Netflix. Thank you so much for coming. And I heard there were some issues with traffic, so we managed to make it kind of in time. So thank you for that. And I just wanted to say a few words about this workshop before I hand it off to our wonderful speaker here today, Becky. Some of you actually came up to me for the event and you were wondering why Netflix is doing this event, the workshop series, what is the motivation behind it. Just wanted to talk about that a little bit, saying motivation is to give back to the community, the Women in Big Data community. To be honest, I did not know Women in Big Data till last year. I was in one of their events. I was giving one of the lightning talks, and then I came to know about this community, and I've been following their meetups. They do such a wonderful job organizing meetups in a lot of different companies and getting people exposed to various different technologies and teams in various companies. So out of all those meetups and follow-up conversations, one thing that stood out was some of the members of the community who were new and they were just getting started with their career. They wanted something more deeper and hands-on and more concrete. The overview talks from different teams were good. It helped them get an overview, but it was not something that they could go back and build on top of, right? So that was one of the motivations. And the second motivation is also from another angle. If you think about it, some of our teammates are working with organizations like Path Forward. These are the companies that help women who are coming back to their careers after having a break in between, either for family reasons or they have been continuing in their career, but they want to pivot. So for whatever reason, women who are trying to pull off a career pivot, and there are some companies and organizations that are helping them and mentoring them. Some of our team members have been having conversations with such companies, and out of all of these, we saw a clear need for having these kinds of workshops. And this is our first time doing something like this, and that's why tomorrow, when we send out a survey on how this workshop was, did it meet your expectations? What is it that we can do to program it in a way to help you get what you want out of this? Please respond and do not ignore that email. And what else did I want to touch on? Yeah, so this meeting is being recorded. You have been warned. There was something else that I wanted to say. Survey, recording, yes. After the workshop is over, please shut down the computers. And if you can leave them by the counter there, it will be very helpful. And if you have any questions or if you need any help, I know some of you are new to MacBooks, you're used to Windows, but we are only offering Macs as the lab machines here. So if you have any, if you need any help, just please raise your hands. We have enough volunteers here to help you out. Other than that, nothing else. So I will give you our speaker today, Becky.
Hi, everyone. My name is Becky Tucker. A little bit about me, and I also want to give you some context on what we're planning to do today. My name is Becky Tucker. I have been at Netflix for about 4 years. I am currently a senior data scientist in content demand and valuation. I work out of our Los Angeles office. I'm actually not based here. I'm up for the day. Prior to Netflix, I was a physicist, so I did a Bachelor of Science and a PhD in physics. And I'm originally from Champaign, Illinois, so I am a Midwestern girl at heart.
Just wanted to check if the mic is on.
I cannot. There I am.
talking.
Better? Okay. And then the other thing that I wanted to say about this presentation is that I really do not particularly enjoy talking to a big group of people who stare back at me. It's nerve-wracking, so I apologize in advance, but B, that also means that I would really encourage you to ask questions, to raise your hand. This is not a save your questions till the end kind of presentation. I welcome them as we go along. It is encouraged. So I'm going to talk, and hopefully not continuously because you're going to ask questions, for 10 to 15 minutes. We'll leave about 10 minutes for questions. I think experience has shown that we'll have to cap that at about 10 minutes. Otherwise, that will bleed over into our time to do a hands-on tutorial. We'll talk more about the tutorial when we get to it. The way it is currently designed is that it should work for you regardless of how comfortable you are with Jupyter and Python notebooks, but we do have a lot of helpful volunteers here if anyone should get stuck. We'll talk more about that at the time. So data science in one slide. This slide is intentionally a giant blob of text because, and I'm sure most of you have questions about this, it's really hard to define what data science is because it depends on the company you're at, the position you're in, maybe even the city or the country that you're in at the moment. It's what I call a rubber band term, right? It stretches to fit almost any definition of something that has to do with data. So to that end, one of the questions I get asked a lot is like, well, what is the difference between data analytics and data science, or between data science and data engineering? The answer is the very unsatisfying, well, it depends. Here at Netflix, there tends to be, it's a blurry division, but there tends to be a division in data scientists are doing more predictive modeling, more machine learning, and our analysts tend to be doing more in-depth analysis and ad hoc statistical work. But that's not true everywhere, and it's not true at every company. So data science, if you're looking to apply to data science jobs and you don't know if you're qualified, my best recommendation to you is actually just look at the skills at the bottom of it to try and get a sense of what they're looking for out of the role. So what I can tell you about is maybe not the life of a data scientist, because I don't think there is any such thing as a prototypical data scientist. But what I can tell you about is a month in my life as a data scientist. And for me, a typical project, a data science project, is on the order of weeks to months. And most of them follow the same arc. We start with a business question. We make a technical plan. So what question are we trying to answer? How do we think we're going to answer it? We make a proof of concept. This is often either a very basic model or a very basic sort of app. Once you have a proof of concept, the phrase that we use is there a there there? You have, at least some inkling that this is not going to be a colossal waste of time. From there, we iterate and validate and communicate back with our stakeholders until we either succeed in what we set out to do or we decide it can't be done. And the decide it can't be done is also a very real outcome sometimes. There are problems that we tackle that are hard and they can't be done either at the time or with the data that we have available. Once you've gotten to a point where you think that you're ready to sort of start wrapping up the project, that's when you start communicating your results back to your stakeholders. Of course, this is not a single step. This is an ongoing process the entire time that you have been developing this model. But there usually is some kind of end cap on the project, either in terms of presentation or an app or a productionalized model, which is your last step. So you have some model. Some places or some problems may not require you to go the full step of productionalization. At Netflix, we typically do, and I'll talk a little bit more about what that means in my context here in a few minutes. So when I say we start with the business questions, the kinds of questions I'm talking about are these. What does the business need, broadly speaking? One of the things I really like about Netflix is that we really focus on what we call context, not control. So in general, I should be aware as a Netflix employee of what is important to Netflix as a business this quarter, this year, the next 5 years. What are we trying to do? So my job is, for example, in content demand valuation. So what we're trying to do is predict demand for content. Who will be using this? This is actually a really key question because your stakeholders may range from other engineers, in which case you can probably be a little more technical and not have to think quite so carefully or quite so hard about how to communicate technical concept, or it may be on the other end where you're working with perhaps like a creative executive, someone for whom this is all foreign language. And if you start throwing around terms like, linear regression or regularization, not only is it going to probably go over their heads, it's also going to cause them to tune you out. So knowing who wants the information from you in the end is also going to tailor how you choose a model, the tension between explainability and accuracy, and then how you get that result back to them. So then once you have this idea, like what is a good proof of concept? Often for a regression problem, the first thing you might do, and this is what we're going to do in the tutorial today, is just try linear regression. See if there's anything there, and it at least gives you a benchline or a benchmark to see, okay, if once I start trying, more fancy feature engineering or fancier ML techniques, am I actually improving on just sort of a very basic, very understandable technique? What is our metric of success? How do I know when I'm done? One of the temptations, particularly for me, I come from academia, is academics always go that last 20%. They dot every I, they cross every T. You're going to go through peer review. You really, really like make sure it is tied up with a bow on top. Something I learned as a data scientist in a company is that you very rarely have to do that in business. It's often enough to say, I've met the criterion for success for this project, and even though I think that I could do more, there's this one more thing I could be trying, at some point you have to realize we've gotten the majority of the value that we're going to get out of this. It's time to move on to the next thing because the first 80% is the most valuable part, and that last 20% is maybe intellectually satisfying, but not as necessary. Another question is, who is responsible for validation? So if I say it's good enough, but my stakeholders don't, it's not good enough yet. If they say it's good enough, but I don't, it's a little more ambiguous. So you have to decide ahead of time, or rather it's helpful to decide ahead of time. How are you deciding when we're done? How will you know when your stakeholders are pleased with the product? What predefined metrics of success are you all going to be looking at and talking about in discussions? Other good questions, what is the time frame? This one's pretty basic. Do you want this in a week? In which case, that might be hard. Obviously I can't take a year. And then of course, what other teams are involved? I work really closely with both our data engineering teams across a couple of different organizations, so both in content and in streaming. And then we have a team called editorial creative. These are folks that actually look at the content itself and give me metadata about our own content. So oftentimes these projects involve coordination amongst 4 or 5 different teams. Sometimes you have a product manager, sometimes you don't. So those are all the questions that are helpful to even get your data science project started. Once you have defined most of those things, you have your technical plan, which is what data do we have available? How clean is it? If we don't have data, can we acquire it? What techniques have other people used to solve problems like this? If you don't have to reinvent the wheel, you definitely never should. And one of the beautiful things about the current state of the data science community is that the open source community and Python packages mean that you very, very rarely have to totally reinvent something, which is beautiful. Then there's the question of what tools should we use? So again, at Netflix, we're in this special, yes?
She had a question.
Oh, I'm sorry, I didn't see you.
Yeah, so you just said, you mentioned Python twice when you were just talking. So is that the majority of the language that you use?
Personally, yes, I am a Python user. R is also really common in data science communities and at Netflix. And then, of course, this is, so I think probably those are the 2 most common tools, but yeah, C++ is also, I think, in the game. MATLAB for some folks is in the game, all of those things. Which brings me to my next point, talking about your tools. So it's usually best to try and stick with the tools your company is already using for minimum friction and ease of adoption. One of the things about Netflix that is interesting and that I really enjoy is, again, in this freedom and responsibility, context, not control. If I really think that there is a tool that we're not using that we should be using, I have the freedom to do that. But then it's also my responsibility to make sure that can be integrated back into our already existing tech stack. What error metric are we optimizing? Depending on what you're predicting, the actual error metric may or may not. The error metric that might be natural to predict from a machine learning perspective may actually not be the thing that your stakeholder cares about. A good example for this might be, let's say you're trying to predict your grade on an exam, right? And so maybe the thing I want to predict is your percentage. Are you going to get a 95% or a 94%? Whereas what your parent cares about is whether you get an A or B. So we need to talk about, am I predicting, are you getting a 94% or 95%, or am I predicting whether you're going to get an A or B? So that's what I mean when I talk about our error metric. And then oftentimes for problems like these, because they're ambiguous, if there's a lot of possible techniques, what I typically do is I say, okay, what are the most promising from top to bottom? I'll start with the most promising technique and work my way down the list. So once we have all of this, then we get to you'll notice this is the first time we actually get to the technical part of this job. So one of the things that I like to emphasize about data science is that it is a very technical, very mathy, very programming heavy job, but it's also bookended on both sides by all of these really, really important communication and business and just logic skills, learning how to take a problem, break it down, and then communicate it back. So I mostly live in SQL and Python. There are always other ways to do this. This is what it looks like for me. I'm usually using SQL to get data out of a data warehouse, do some manipulations, do some cleaning. I mostly do prototyping with Python, often in Jupyter notebooks, sometimes just with a standard editor. And I'm using most of the standard machine learning packages that people have in the world. So just by show of hands, anyone who has heard of ML, okay, anyone who's used ML, anyone who feels comfortable with ML. Okay, cool, that's just for me to level set later. Seems like most of you are familiar with what machine learning is, broadly speaking. Within that, there are tons and tons of specializations and techniques, and most of them have already been made available to you via Python programming packages that somebody else in the world has already written. The most common of these, I think, that you'll find in tutorials is something called scikit-learn. That covers everything from your basic linear regression all the way through some of your more advanced nonlinear methods. XGBoost is a optimized version of some of those algorithms that's often faster. Keras is my personal favorite package for programming neural networks and doing deep learning. And then another thing that we're going to see in the tutorial that I work with day in and day out is pandas. And pandas is a Python package that is really, really helpful just for data manipulation. You put data into something like a data frame, which you can think of as like a table, and then it provides you a lot of ways to access that data and clean it and move it around and transform it in ways that are helpful to get it into whatever algorithm you're using. I find that for me, my early results are often passed back and forth with my stakeholders via spreadsheets and documents. It's pretty low tech. One really important part of this is that none of us works in isolation. I have a whole team of people that work with me. So we meet together, we talk debugging, we talk modeling suggestions. They give me advice, I give them advice. And then for me, my early visualization of what I'm doing is typically not fancy. I'm making plots in Python or maybe a basic Tableau dashboard. If we need to do something that is more advanced for visualization, my team actually has the really great fortune of having what we call a prototyper. And she is awesome, and she can throw up like a data visualization and an app in like an afternoon and like it's wonderful because like all of a sudden your stuff like goes from this janky hacked together Python code and then it looks amazing. And everyone's like, oh, it's so great. And you're like, yes. Yeah.
Do you guys use D3 or what do you use?
There are folks at Netflix using D3 for visualization. Our prototyper, I think, is mostly working with JavaScript, which I think could also be D3. That's honestly outside of my area of expertise. Other questions? Yes.
So you talk about your prototyping in Python, but when you're like moving into production, are you still utilizing Python or?
Yeah, I'm still utilizing Python mostly. It's just that my prototyping code is typically riddled with very inelegant comments. Most of, like inelegant code, inelegant comments, and you can often even sort of trace back my thought process where I've commented out the same line 3 times in a row because I'm trying different things with each one. And so before something goes into production, I would go back through and probably refactor that code before other people lay eyes on it. So this is actually the sort of problem that we are going to mostly be looking at in a simplified version during the tutorial. And this is sort of the prototyping, iterating process that I talked about, where you have your problem, you have your data. Our data is already going to be labeled, so we won't have to worry about that. But this is kind of your process. You get your data, you look at it, you understand it, you split it into training and test sets. We'll talk more about those. You create features, you do your model training, and then at the end you decide, is this good enough or do I need to try it again? And so this is sort of the high level version of what we're going to be also doing in the tutorial. I just thought it would be nice to sort of give people a visual reference. Yeah.
I saw the label data and the feature extractions. I'm wondering for Netflix, do you do more supervised learning or unsupervised learning approach-wise? Which approach is majority for machine learning?
So broadly speaking, at Netflix, we do a lot of both. My personal work is mostly focused on supervised machine learning.
So the label-wise, like you meant, how do you do the label part?
I'm mostly using our internal data. So it's when I say it's already labeled, I mean that I already have the target value that I want to predict.
Okay.
All right. And then this is the productionalize the bubble part. This I think is something that was not maybe as standard when I started in data science 4 years ago. It's becoming more common now, I think. So by show of hands again, who knows what an API is? Who's written an API? Okay, that's actually fair money. Okay, cool. Service level agreement. Okay, few of you. So when I first started in data science, I definitely did not know how to write an API. I barely knew what it was. And then at some point, as our organization grew and scaled, and someone said like, hey, in order for people to consume this, we need to have it behind an API. I realized, okay, this is a thing I need to know how to do. And so that is, I think, probably for me, one of the most common ways that I productionalize a model. So in addition to doing a code review, refactoring my code so that it is, easy to read, easy to understand, when in 6 months I have to go back to it or someone else has to pick it up. And then giving other people access to it. And so right now APIs, I think, are my preferred way of doing that, because they don't have to. One of the things I really like about it is that I can continue to upgrade and update the model on my end. And as long as I don't break the API, it is completely seamless to my end user. But one of the things that happens is that, and this is one of the things that is really team dependent. On my team, we mostly do productionalization ourselves. We don't have, for example, like ML engineers that put things into production for us. There are some teams where data scientists do prototyping and then they hand it off. So when you're doing productionalization yourself, you really need to talk to your stakeholders about a service level agreement. And what I mean when I say that is, do you expect this API to be up and working 90% of the time, 99% of the time, 99.99% of the time? And when it breaks, do you expect me to fix it this hour, today, or this week? Because my strength is really not in production code. And so identifying ahead of time, like, okay, if this is something that really is neat, has these like tight bounds on it, people need it, and they need it to work all the time really reliably, this is when I know I need to pull someone else in to help me with this, because that's not my area of strength. If on the other hand, it's something where like, if it goes down for a day, it's no big deal, then that's something I feel comfortable doing myself. before something goes into production, again, I go back, I refactor my code, I document with good comments. Philosophies vary about whether you should document your code with comments. We can have that discussion too at some other time. And then, of course, documenting your results with your stakeholders, with documents, presentations, socializing it is also a really important thing. So I made this really great thing. Now I want people to use it. If they don't know about it, that's going to be hard. So, okay. That was all I had for the meat of this presentation. And this is the time for questions if anyone has them.
Let's say you're training a model, and sometimes the training model takes days or weeks, and you don't want to wait until the end of the day that you get the result. If that's wrong, then how do you determine whether the model that you're using or the parameter that you're using, how do you determine earlier stage if the model is not working?
That is, to be honest, not something I deal with a lot because despite the fact that I work at Netflix, I actually work in a relatively small to medium data world. So I actually don't have a lot of experience with the kinds of models that take days and days to train. If someone asked me that question in an interview, I would probably, my first instinct is of course to downsample, but I'm sure that there are way more interesting ways to deal with that problem than I know about.
So we mentioned small or medium size. What's the data size, for example, if Netflix you consider is medium, small size?
If it fits in memory on my laptop, it is not big data.
I was wondering, you mentioned like your process for working, and it seems like you're solving a lot of these problems mainly by yourself. And I was wondering, is there ever like a time where you have team members all working on the same problem or same?
Yeah, absolutely. So, I mean, there is some aspect of this where at the end of the day, unless you're pair programming, which is also a good thing, you do have some slice of a problem that is yours to sort of own and move forward with. But the primary, actually, most of my work up until now has been actually done on a shared model suite where me and 2 or 3 other coworkers were all collaborating on the exact same model suite. So, and so in that case, yeah, it was highly collaborative. And the way that worked for us in practice was having a really good culture of Git cleanliness, lots of pull requests, lots of discussion about changes to the models and who was going to tackle what sort of specific problem. Yeah.
Once a model is out in production, do you have any QA system testing and validating that on production size data? And that is, if there's an issue with a model, do you just release a new model? Or do you try and unlearn and unpick things? So for instance, in terms of recommendations, you recommend things based on what people have viewed before. What if you're seeing that people who watch really depressing, sad things should not be recommended more depressing, sad things in the middle? And, then that's like an edge case. So one, I wonder, like when your models go out, are you also validating it post-production, in production data, in the wild with all of the other goings on and changings that are being done? And if there is a problem with something that's actually out in production, do you solve it with a new model, or is there a different way with which you approach it?
Yeah, the answer to that is, I'm sorry to say, it depends. Because there are a lot of models flying around Netflix. So I don't work on recommendations. I actually can't speak to how they deal with their models in the wild. My models in the wild still do not reach subscribers. So all of my models are internal facing, which means that so we have our own internal validation and regression testing frameworks that continue to run after the model is live. And then of course our stakeholders, if they start seeing strange things in the model, you betcha we're going to hear about it. So we get that feedback relatively quickly.
What are the typical metrics of success in Netflix? Say, typically an output of a model would be like either a trend or an insight or some kind of prediction. So the stakeholder would ask you, right, that how does this now correlate to the revenue and how is this going to be helpful? So what are the typical metrics of success you use?
For content demand, we work mostly with root mean squared error for our metric on our models themselves. And then other than that, it it gets a little fuzzy, to be honest. So a lot of it has to do with model adoption. So for example, I'm working in content demand valuation, which focuses, or rather the models themselves, or the outputs of the models are used to determine our willingness to pay for certain kinds of content. And one of my personal metrics of success is, are the people who are doing those valuations, what percentage of the time are they using the model results versus some other process? If they're using it the majority of the time, I consider that a win. If they're ignoring the outputs of this model for whatever reason, and often it's very legitimate. I mean, that's one of the things that I think people underestimate about machine learning is that you're going up against domain experts, the people who are the very best in their field. So yeah, it probably is a lot easier for my machine learning model to outdo like Joe Schmo on the street. It's a lot harder for it to outdo someone who's been in this industry for 30 years. So if they're finding it helpful, if they're using it in their work, I consider that a metric of success.
With what you were just saying, do you take that domain expertise that maybe your stakeholder has, and do you try to then feed it back in by retweaking the model? Or
yeah, that's something we're really learning a lot about right now. I think of that as human in the loop prediction. And the problem with human in the loop prediction is that it's hard because you have to have good data systems in place in order to really capture that and capture it in a systematic way. But I think, and this is more of a personal opinion, I think long term that we're going to find that human plus ML together does much better on any prediction problem than either human alone or ML alone.
Have you had stakeholders come back and say, can you tweak this so the numbers look like this? Because that's what I've experienced, especially with predictive models. They're like, I have a meeting tomorrow. Can you give me 3 and I'll pick the one that I want?
I think this is human nature. So luckily for me, there are times I think when people want to go on fishing expeditions, or what I call fishing expeditions. Luckily for me, Netflix is a very data-driven place, and it is data-driven from the top down. Our CEO cares about data, and it flows all the way down through the organization. And so people do at least embrace the challenge of me saying, for example, is my skepticism about a question, or me challenging them on what question are you really asking. And by and large, that's a really productive and good conversation here. And I find that in practice, people understand that to do that destroys the sort of the validity and the value of the model. So here, at least, we have that conversation sometimes, but it mostly seems to work out very reasonably.
I've been studying ML and deep learning some time, but I was not really paying attention to the statistics. And I was told that the data scientists, they use model, they use data, they also use statistics a lot. For you, how much the knowledge of statistics is used actually in Netflix?
For me, it's pretty important. I think even more so for some of our folks that are doing like causal inference and IB analysis and other areas. So my specialization is in supervised learning, really, and the types of statistics you need to know that are pretty well defined, and they're pretty accessible. There are some folks in the company that are doing statistics that are way nuanced and like way graduate level in a way that even I don't totally understand. For me, the importance of statistics is understanding, for example, things like why, like trying to explain to a stakeholder why it's a bad idea to continue to slice their data to look for effects, or why they cannot take a result that's based on not enough samples and run with it. And just having the intuition there of like trying to have that back and forth of saying like, okay, I know that this signal looks really exciting right now, but here's why it's probably random noise. And like having the statistics background to have those kinds of conversations is where I find it most useful. All right.
I have a last question.
Yes.
Do you get to publish?
Sorry?
Do you get to publish your research result?
I personally have never published, but there are folks at Netflix who have. So it is not a hard and fast rule either way.
You mentioned you're not from this location, but I missed where you are from. And if
Oh.
you talk about data science positions, 'cause, I'm interested in data science and I know others who are. So are there particular Netflix locations that have more data scientists and engineers than others?
Yes, I'm from Los Angeles. And in terms of Netflix, we only have data scientists in these two locations. So up here and in Los Angeles, and the vast majority of them are actually up here. The data science team in LA is about 10 to 20 people. And then I guess once you include all like data engineering, all of data in LA is roughly 50 people. And then all of data up here is roughly like 150 to 200 people. And so that's mostly where they are. And then data science in LA is definitely growing, but it is not anything like the scale that it is here or in New York City.
Thanks.
I saw that you had a major physics, and how much the physics knowledge do you use in data science? And also, the works that you're doing, do you really like it?
So the first question is, how much of physics do I use? So yeah, quantum mechanics, not that helpful. But what was transferable was the mathematics and the programming. I was an experimentalist, so I did a fair amount of data manipulation and programming. So those were all transferable. The ability to take a question and break it down and solve it, that's a transferable skill, I think, from science. And then lastly, the ability to teach yourself new things quickly is something that I think every PhD student sort of has to acquire. In terms of the deeper question there, so a lot of physics is based on linear algebra in the same way that a lot of machine learning is, and there's some pretty deep connections between, for example, like statistical mechanics and information theory. And having that background does make that diving into that field a lot easier because a lot of it is the same math with different words. And once you sort of flip that switch and you realize like, oh, this is, for example, like just a Boltzmann distribution. I know this from this other context. It's a lot easier, I think, to ramp up on that kind of thing. What was your second question?
Do you really like it?
Oh.
Being a data scientist?
Yes, actually, I love it. Yeah, no, it's this. I occasionally bemoan the fact that, and this is not a real complaint, but this is like I think maybe the best job I'll ever have, and so I'm a little bummed that it was the first one because I'm not sure there's anywhere to go from here. But but there are worse problems to have in life. Cool. All right. We're going to ignore the first bullet point today. So I was thinking of having people try and like pair people who are more experienced with the people who are less experienced. But I think instead, I just want to remind you that you are allowed to ask people sitting near you to collaborate on things and to help with things. So please go to the following URL, also written here if we navigate away from this page. Oh, password to your computers is Netflix, lowercase. Okay, by show of hands, who is not able to access their computer? Great. Who has not found the webpage? Who has not downloaded? Okay, not webpage yet.
Please let us know if you need any help.
You have to go one up and there's no, I'm going there, there's no data in there. go to data science, there's no file.
It's gonna look like this.
So go data science. So there's no.
Oh, okay.
You're gonna download the zip file
Yeah.
and unzip the zip file.
Oh, okay, because when I opened the computer, that page was already there, so.
Okay.
So, when I opened the computer, it was already there.
If there's anyone who doesn't know how to find their
Okay, so
terminal,
I'm gonna do the, so that's the not.
Is it somebody's brand, not the master? So
Let me do this.
just delete them.
if you do not know how to find your terminal, you can click on the spotlight in the upper right-hand corner of your screen and type terminal into that search box and hit enter, and you will get a terminal if you need it.
Yes, in my episode.
Okay. By show of hands, who has the notebook launched? Okay.
So you need to start your commands and type terminal. You can just. And then you can do Jupyter notebook. Okay, so
Yeah, this is good. Okay, so yeah, and you might need to unzip a data folder as well within after you unzip it.
All right. Cool. So if you just command space. And then terminal.
Sorry, can I just ask, do you use Jupyter Labs, or what do you use for collaborative cloud-based Jupyter notebooks? Because I've had issues with this in the past.
Yeah, we have an internal service we call Commuter, which allows us to share just regular Jupyter notebooks back and forth.
And just like, actually, you do it as like properly collaborative Google Doc, tons of people in at the same time.
No, we haven't solved that.
Oh, okay.
Yeah.
So,
Yeah, this.
Jupyter Labs is supposed to come out with something like this.
Enter and then, no. And then type that CD down.
Yeah, and we hit that issue in terminal. I think there's sometimes not clashing.
Is there anyone who needs help who is not currently getting it?
I also said the first one at home is dot IPMINV.
Becky says. All right.
Are you on command line? Yes, so this is, it opened.
About Jupyter.
Yeah.
How long have you been using Jupyter? 'Cause I kind of feel like it came out of nowhere and now it's everywhere. Or have you been using it a long time?
I've been using it a long time. I was using it in graduate school, so I
Okay.
think maybe it like filtered into the academic world first
Okay.
before it hit industry, but I'm not sure.
Okay, yeah, because I've been in industry and I just feel like all of a sudden everyone's like, Jupyter.
Yeah.
Okay.
But before that, it was called IPython Notebook. Those are actually the same product.
Yeah,
I don't know.
yeah. Okay.
That's what I was gonna say.
Ah,
That was
okay.
Python before.
Gotcha.
So they were.
Oh, okay. So if you already had this on your, if you already had the folder on your laptop, you are going to need to re-download it and navigate to the new one because there are updates to the notebook from the previous session.
If you have any doubts about that, please.
Yeah, if you have questions about that, please let one of us know. It's a quick fix.
How do you know whether you're on the old one or the new one?
Did you download it today or was it already on there?
I downloaded it, but I don't know if I downloaded it twice and then
Go to 2.
go to.
I think if you're able to get to this file, this iPython notebook, then it's a.
I was trying to open it to see if I could start it, but somehow it didn't work, so we just hide in there.
I just had
She just came and typed in my computer and went, okay, magically.
Oh, you should be there.
Yes, I do.
Okay.
This is,
It was right. So,
there were two.
Once you have your notebook launched, it will look like this. You'll want to click on this one at the end. That's .ipynotebook at the end. And you should end up with something that looks like this. By show of hands, who is on this screen?
Downloads, okay. The master one I talked to.
Okay.
Does anyone need help? Is anyone not in this? Okay, so you get out of lines.
let's look inside here. This is two, so you see. So with that one, then you do who's the data scientist? So we're going to data science. Yeah, that's a big computer. But that's
Okay, I think we are all more or less in the same place. So the good news about this notebook, actually, sorry, one more crowd question. Who is not super comfortable with notebooks? Everybody is, okay, a couple people who are only kind of okay with notebooks. Okay, so the way this works is that when you hit run, your notebook here is divided into cells. Cells that look like this notebook setup, these are just text cells, they don't do anything. The ones that look like this, these are cells with code in them. When you hit run, they will run the code in that cell. In order to make the cell below it execute, you do have to execute the one above it in order. So the way that this notebook is set up, you can just hit this run button and it will go through everything in the notebook without you having to type anything. So if you get stuck or you get to a point where, like, for some reason something is erroring, you can always come back up to the top of the notebook, click run, and go back through everything, and then it should just work again. And obviously, if you get stuck, that is what we're all here for. So I'm going to have everyone just execute the first three cells. And what these, the scroll on this is opposite of my usual scroll. So what is happening here is the first cell is just this text. This is just my personal favorite piece of code that makes it so that it uses the entire width of your screen because I like being able to see the entire width of my screen. And then these are your standard Python packages that you're going to use for most of this. So pandas, which I mentioned earlier, which is a data analysis package. NumPy, which is a really common package that has most of your like mathematical functions in it. Matplotlib, which we're going to use to create a couple of plots. And OS, which is just it's a way to access files on your computer for this tutorial. So starting with the first part of our business question. For today's tutorial, we're using the World Development Indicators dataset, which some of you will already have encountered in your previous tutorials. This data set is essentially a data set by country, by year, that has just all kinds of interesting information about countries. So everything from populations, death rates, deaths due to certain kinds of diseases, business information, educational information, agricultural information. And so this is a really rich data set. It's super fun to play with if you ever want to go do that on your own. But today we're going to focus on one question in particular. So today our business question is, how hard is it to start a business in different countries? Maybe, this is of interest to you because you are a minister of some country that wants to make your country more business friendly, or maybe you're a CEO trying to start a company, who knows? So this idea of like, well, how hard is it to start a business? Well, that's a pretty vague question already. So we're gonna take that further down. What do you need to start a business? You need time and you need money. And those two things are almost certainly correlated. And the other things that may affect your ability to start a business would include the regulatory environment, general level of prosperity in the country, the number of people from whom you can draw your employees, and so forth. So for this tutorial, we're going to try to predict the cost of starting a business in countries around the world, given some information about that country. And so this is going to be a supervised learning example. So in this case, we have our training examples with label data. So in this case, our label is going to be the startup cost. And all of our input variables are going to be things that we have already pulled out of this data set. We'll talk a little bit more about that. And then when this training process is finished, we'll have a function that can be used to estimate the cost of starting a business for, well, it's hard to imagine a country you've never thought of, but for example, if you thought of like, well, what if we changed a variable? What if my country changed this underlying thing? How would this change the answer? Which is the kind of question you might be interested in. So this is a pretty classic regression problem. We're predicting a continuous target variable. So the cost to start a business, when I say it's a continuous variable, I mean that your cost to start a business can have a decimal value, essentially. It's not 0 or 1, which is something categorical, and it's not 1, 2, 3, 4, 5, which would be something ordinal. And our input features are going to be things like the regulatory environment, the number of people, and so forth. So we're going to start by getting our data. All of this data has been pre-processed for us. And we're going to import it from our CSV files into Pandas data frames. And the idea of a data frame is that it essentially takes your CSV, it pulls it into memory, and you have essentially a table that you can reference by columns and rows, which gives you a really nice way to access and slice your data in different ways. So we're going to go ahead and run these 3 cells. And so what's happening in this first cell is that we're just saying, this is the data directory. That dot means I'm already in the right place. These are the names of our files. We're going to talk a little bit more about what's in each one of them. And then this is the command that says, okay, given my directory, given my file name, please read this in so that I have access to this data. So these are prepared data files, and what you're going to get in your business data frame is going to go by country, and it's going to have the startup cost, the startup time, the ease of doing business, the population, the number of broadband subscriptions in that country, the number of cell phone subscriptions in that country, the percentage of the population over the age of 65, and the GNI, the gross national income per capita. So that's going to be kind of the core thing that we're mostly working with. We also have a couple of additional data frames, that one of which we're going to use to help us fill in some missing data. So one is a country data frame where we just have information about the country. So we have its name, we have its region, and we have an income group. So is it high, medium, low? And then these other 2 data frames are really here as exercises for the reader. They're just 2 additional data frames that have by region and year, or by country and year, the population of number of broadband and cellular subscriptions. These are in here for you to play around with, try to match it against, if you want to download this later, try and match it against your, the existing data frame, see what you can do with it. So that's just to give you an easy way to explore. So one of the things that I like to do is, now that I have this data in, I just want to look at it. So if you run this here, you're just going to get the first 5 rows of your data frame, the head. And so you'll see that we have a country name and we have all of our variables. understand how this thing scrolls. Maybe it doesn't. Okay. So we have our country name. We have our startup cost, which is a percentage of GNI per capita. So this is going to be our target variable. The startup time in days, the number of startup procedures it takes to actually start a business, the ease of doing business, the population of that country, the broadband subscriptions, and so forth. The other thing that we might be interested in here is what our country data frame looks like, and you can do the same thing. And so here we just have the country and some information about them.
Why the population data is decimal?
Sorry?
Why the population data is decimal?
Why the,
Population data is decimal. Means it's fraction or a percent. No, I mean, in this table, if you go business, yeah,
this one?
yeah,
That's a good observation.
Why is what fractional? I'm sorry.
it's fractional. I mean,
Population
is not to answer my question.
It's a decimal.
Oh, yeah, it should be an integer. Yeah, you can't have, a half a person. That is correct. Part of that is, so the reason that this happens is that when Pandas reads in this data, it actually doesn't know what data type any of the columns are. And so it's guessing. And in this case, it guessed it was a float, which will work for most purposes. It is actually an integer in this case. But yes, that is an excellent observation. The other thing you might observe is that there are in fact nans in this data set. One thing that I'm not clear on is why I can't scroll. Oh, there we go. So sorry, the reason that I am having trouble here is that everything is exactly backwards of my usual laptop. Yeah, so we have cellular subscriptions, the percentage of the population that's above the age of 65, and then the GNI per capita. So we're going to use all of this data to try and predict the thing we're interested in, which is the startup cost. Questions thus far?
So it says that my file does not exist, but I follow the instructions.
Okay. My guess is that there's a path set wrong somewhere. Or that you're in the old, the previously downloaded version of this.
So it happened to me too. So I did all the whatever existing ones and download again. The previous version, there's no file.
Yeah, the previous version of that zip file doesn't have this tutorial in it. So you have to re-download it if this is happening to you. So one of the first things that you are likely to be interested in is just, what does my data look like? How big is it? So in this case, when I click on businessdataframe.shape, I get back the shape of my data. It's 221 rows long and it's 10 fields wide. In the world of data, this is small data. This is micro data. This is toy data that you use in the tutorial. But in other cases, this is going to be a really informative thing because, of course, you have issues if, for example, your table is much wider than it is long, or if your table is so large that your chosen algorithm is going to have a hard time training. The size and shape of your data is something that you'll become vitally interested in. The other thing you can do, if in particular something like this where it might be ordered, is you can also just sample from your data frame. So here, for example, we're sampling from one of the other data frames that's available in here. And it's just a random sample. It's just a way to kind of look at it and see what's going on with this data, make observations like the fact that some of the columns may have their own type, that there are nans in some of the columns, that sort of thing. Another nifty function in Pandas is the describe function. And so what this does is for every column, it gives you the number of fields, the mean, standard deviations, percentiles, and the mins and maxes of each column. So you can get a sense, for example, if, so like for me, one thing I would look for is for the mins, are there any columns that are negative that shouldn't be? Are there any that have nans? So like, the count, it should probably be 221 across the board, but ease of business is 177, which means I probably have nans in that column. other things to look for. This is pretty sensible data, but depending on where your data is sourced from, looking for infinite values, because that's definitely going to be a problem when you try and fit on something. And this is another area where having some domain expertise is really helpful so that you have a sense of like, is this a reasonable number or not? So like if you're working with box office data, for example, is it reasonable to have a box office of $7 trillion for a movie? No. Is $100 million reasonable? Definitely yes, right? And so having a sense of like, are these numbers in the right ballpark, right? And if, you know, it's gut check, it's building your intuition, that kind of thing. So in this case, we know there are nans in the data, which means we're going to have to fix them before we do anything with them. And so here is a nifty way to just figure out where are all my nans. In this case, they happen to be in the fields ease of starting business, and then a few mostly in that field, and then a few in broadband subscriptions and cellular subscriptions, and then a few in the percentage of population age 65 and above. So does anyone have ideas for why nans in your data are a problem?
Whenever you doing some transformations, they won't convert it to 0 or something else. It will just crap out and say, there's not a number in here. We don't know how you want to treat this.
Yeah, absolutely.
Divided by 0, it kind of goes, ugh.
Yeah, absolutely. Other thoughts? Why nans are problems?
If the factor that comes out as being the most significant in your model is something that has a lot of nans in it, then it is a problem because you're basing your model on something that is not entirely accurate.
Yeah, absolutely. Yeah, often you find these really wicked things in your data where you have something that is like super, super predictive. And then it turns out that that variable is only filled in like 1% of the time. And, you know, you're like, great, if only everybody, you know, had this characteristic or knew about this character, like, you know, if only we knew about this for every piece of data, and it just doesn't work that way. And exactly right. There's a lot of machine learning algorithms that do not handle missing data, most of them, in fact. And so you will have to decide what to do with them. So this is just sort of looking at, you know, where are my nans coming from? One interesting thing about this data set is that the nans are mostly coming from countries that aren't actually countries. It's things like, you know, OECD members, Caribbean small states. For our purposes, we're still just going to pretend these are countries because otherwise our very small sample size becomes even smaller. But we do have to deal with these missing data sets. So this is mostly goes under the guise of imputation. As someone mentioned, you can fill these with zeros. Any thoughts about any thoughts about why filling with zero is a good or bad thing?
Might skew the whole population, the average data to this side.
Yep. Yeah, if you say something is zero, that might have a meaning in your data set that is different from missing. Someone is saying that someone is 0 years old is different from saying they're missing, you know, in sort of the most basic level of that.
If 0 is category in your data and it gives the output as 0, then it's actually giving you the wrong category.
Yeah, also true. Another popular way to do imputation is by filling with the mean. This avoids that problem of skewing with your zeros. It can also have some kind of strange effects depending on you know what you're doing. So like, for example, if you're doing prediction on films and you're looking at box office, a lot of films have box office missing because they were never theatrically released. And so then the question is, well, did they have 0 box office? Not really, because it's not like they were released and nobody went to go see them. But if you fill them with the mean of box office, that doesn't make a whole lot of sense either, because we don't know that they would have been a mean or average movie had they been released. So one of the things you can do in that case is actually set it to a value and then also have an indicator variable. So it would be something like box office is missing, or, you know, this information is missing. And then you have like a categorical that's 0 or 1. It's a fairly common way to handle that. So, so what we can do is now we have 2 data frames here, one where we're just filling with 0, one where we're just filling with the mean. And then we're going to do one slightly clever thing with our data set, which is to say, well, rather than just filling everything that's missing with the mean across every country, we're going to try and be slightly clever about how we do this. And we're actually going to try and fill it with a smart mean. And by that, I'm going to say, it's like, well, if I'm a low income country, then maybe I'm going to take the mean from other low income countries and fill it in if I'm missing. And if I'm a medium income country, I'm going to do from medium income countries. And if I'm a high income country, I'm going to do it from those. And so what follows is a lot of pandas. And so I include this not because I really expect us to walk this through in detail. And in fact, it's totally fine if you just click through all of this to get to the end. That's more or less what we're going to do. The reason that I include this is that this kind of thing is the not so secret of data science. You will spend a lot of your time fixing your data and getting it into a form that works for whatever you're trying to do. And so it is to your advantage to become good at these skills, because the least amount of time that you can spend on this portion of your work, which for me is the boring bit, the more time you have to spend on the good, interesting bits. So, it's rather than avoiding it because you don't like it, my recommendation is actually just get so good at it that you can just get it done and then move on to the more interesting bits.
So have you had some cases because the data was so low quality, which was too many missing pieces, and you went back to your stakeholders saying, well, the data I have is not really good enough for me to do this case. And what would be normally your reference as a threshold, percentage-wise for that?
Yeah, that definitely is something that happens for various reasons. Sometimes the data just doesn't exist, or it hasn't been in existence for very long. And the threshold is typically if given the state of this data, we're not even going to get to anywhere close to something they're going to be able to really use. Like if I'm not going to get to a result that's going to be better than what they can already intuit based on their industry experience, then in that case, it's not worth doing. And so it depends on the data and it depends on the use case in terms of what that threshold actually is. I would say for most of my work, if the number of samples of any particular thing is fewer than a couple thousand, that's the part where it just starts to get really, really hard. Not that it necessarily can't be done or can't be useful. It's just that's the level at which you start really running into a lot of problems.
Validator.
Yeah, when your final data set is only on the order of hundreds, then you start having not enough data to really sink into. Cool. So one of the interesting bits about Pandas is that it lets you do group bys the same way you can do in SQL. I really enjoy that feature. That's what's happening here. We're grouping by the income group and then taking the mean at an income group. And then we're joining that back to the original data frame. And then here we're filling with the means based on that. So that's more or less what's happening in here. And then we have this data frame, business data frame fill mean, and fill mean smart or fill smart. And so now you have three choices for your imputation of missing data. So is there anyone who was not able to get down to step 6 or here where I've got the pair plots? Cool. So we spent a lot of time looking at data tables, which is good, but then you also need to zoom out and get kind of a higher level idea of what your data looks like. One of my favorite ways to do this is by doing a series of pair plots. And what a pair plot essentially is it takes all of the variables in your data set and plots them against every other variable. And then usually along the diagonal, you have a histogram to get a sense of what the distribution of your data is. So in this case, we're coloring by the target variable in question. And so actually, I'm curious, when you look at this series of plots, what stands out to you? So the kinds of things I look for are For example, cases where, like this here, where it appears not to matter, like this variable appears not to matter in terms of like, there's no real correlation here between like startup cost and you know, some of these other variables, right? Like it's not very informative. Whereas here, right, like you're starting to get some idea of like there's a linear sort of thing happening here. That means there might be information in this variable. Cases where you see that two variables look really similar to each other, or like over here, you might start thinking like, oh, maybe these variables are collinear. So like broadband population and cellular population, broadband subscriptions and cellular subscriptions, right? These two columns, they look really similar to each other. So my guess is that you could probably include just one of them and get roughly the same amount of information. All right.
How, in those situations, how do we make sure it's not correlated with other parameters as well? So like, you know, they may be correlated, but no, maybe it has other factor also correlated with that multiples variables together. So in that situation, normally do we do additional approach to?
So there's a few things. So the visualization aspect of it is limited because of that. You can either go through feature selection techniques, and there are a lot of those that essentially are ways to either like a really simple one would be to, once you've run your model, go through and drop every single variable one by one and see how much it changes, to see how much they matter with each other. Or there are feature selection techniques that can help with this, or you choose a model type that deals really well with collinear relationships.
But normally, typical, how many different models you will try before? Typical, I'm just wondering, typical, you'll try pick the top 3 method to run, then you move on to the decision, or normally you will run it more, or what's normally average?
I would say I at least, almost always at least start with something like a linear or logistic regression just to get a sense of things. My personal experience is that most tree-based methods, so like random forest or gradient boosting, are kind of like the workhorses of most prediction problems. So generally, one of those two things with hyperparameter tuning gets me to where I need to go, and then it's really only like very specialized problems that are, or things that are really intractable, that I would try something like deep learning or, you know, other techniques. Like, I mean, it also depends on what you're doing. Like I live in this very sort of like supervised ML land. Yeah.
Should you even normalize the data that needs normalizing? So broadband subscriptions to cellular subscriptions are basically just the population because they're absolute numbers, so it tells you nothing.
Yeah.
So like it should be like per thousand.
Yeah,
it
totally.
Should be in any way useful.
Yeah.
So that's kind of, would you always go and just like default normalize everything that you think should be normalized?
Yeah, so absolutely. So I didn't cover that here because there's just so much stuff that like I wasn't totally sure what to cover in this and whatnot. But yeah, absolutely. For most applications, you do want to normalize, or you want to think about like what your output range is. So like if for example your target variable, you know, I have an example where like my target variable ranges over like 6 orders of magnitude, which is really hard for a prediction problem. So we like take a log transform there. So yeah, absolutely. And oftentimes there are a lot of particularly tree-based methods where they are really great because they're super insensitive to normalization. You can really just throw stuff at them and they work. But for something like a linear regression, then you definitely need to think about that beforehand. Cool. So we have some data, we filled in missing values, and now we are going to just get our baseline results. And so the first thing that we're going to do is try a simple linear regression and just see how that does. In order to do that, we need to split our data into a training and testing set. That's what this function here does. And then down here, this is where we actually say, okay, we're going to take my business data frame. We're going to take 80% of it for training and the rest of it is testing. So I set my validation percent here to 0, just for the example of this problem. And if you do that, we can see that we're going to have 176 points in our training set and 45 points in our testing set. And so my question for you guys is, who has a sense of why we split into a training and testing set?
So training and testing, normally sometimes they also do validate data sets, like, because the training, once you trained, your model will be kind of already leading to kind of matching the results that watch separate into their training, testing, and also validating.
You don't want to cause overfitting by training a model on the entire data set. You want
Absolutely.
to be able to do well on any data you give it.
Absolutely. Did everyone hear that?
And
Okay.
also tuning hyperparameters.
Also tuning hyperparameters. Absolutely. So, the main reason that you always want to make sure you have a holdout sample is that you want your model to generalize. You want your model to do well on data it has never seen. And so we split our data into data the model gets to see in order to figure out all of its coefficients and parameters, and data the model doesn't get to see until we're testing at the very end. As many of you have astutely pointed out, it is often standard practice to also have what we call a validation data set. So you have a training data set, then you have a validation data set that's often used to tune hyperparameters or to do other kinds of things, because this might be too much for this tutorial, but oftentimes when you're using a holdout data set repeatedly to sort of tune a model, the model still gets to peek into it, and so it's not truly a holdout data set. So then you need this like truly held out testing set that never touches any part of the model training process to really get a sense of how well your model generalizes on data it's never seen. Yeah.
Just out of curiosity, because Netflix has like 200 data scientists, do you have like a set practice that you expect everyone to follow? Because, like, say, always set this percentage aside, always like make sure you set a seed and bootstrap this many times, just because you can give the same data set to 50 different data science teams and they'll all come out with a slightly different model and sometimes actually different answers, because they'll decide to tweak things in different ways. They'll run bootstrapping how many times, they'll start sampling things differently, they'll sample them at different points. So because you have this many data scientists and a lot of things are model based, do you have a set practice?
No, so Netflix is not big on process. That is not something that we really do. In general, we tend to say everyone we hire has fantastic judgment and is an expert in their field, and we trust everyone to know what they're doing and to not need a process like that in order to train a really great model. And so there are certainly best practices, right? Like, I think if we hired someone and they had never like split their data into training and testing set, we might question why they got hired. So like, I mean, there obviously is some base level, but no, that's not something that we set. Also because most of the data scientists, or not most, but we're all working on such really, really different projects. So some people aren't doing supervised machine learning at all. They're doing optimization research, or they're doing, causal modeling, or, all these other things where maybe it doesn't all apply. To your second point, one of my rules of thumb actually is that if the outcome of your model really depends wildly on something like a minor tweak to a model algorithm, or the number of times you bootstrap sample, if it's really sensitive to those things, you really have to take a step back and question if you're actually just modeling noise. If there's signal there, almost every model you try should find that signal and come up with roughly the same answer. Maybe it varies. Obviously, it has to vary if you're using a different algorithm or whatever. But if you're getting wildly different answers, that to me does not pass the smell test. There is something else going on. You're either modeling noise, or you're missing a reason why one of those models is really sensitive to something in your data. Because this is not, it's not magic. It's like the reason that we're doing this is that we do think that there is real information and real relationships that we are trying to tease out of this data. And that's all these algorithms are doing, right? Is they're systematically in their own way trying to find ways to get at whatever this kind of underlying latent information is. And if you really believe that that information is in there, then most of them should, like most of these are really just function approximators, right? Like they're searching for whatever that function is. Most of them should get kind of close to the same answer, unless you're getting like trapped in some weird local minimum for some reason, in which case you need to rethink, what it is you're actually doing. So in cases like that, I would actually advise people to like take a step back and think harder about what they're trying to do. Cool. So we're going to split our data now. And so we've got our X's and Y's, and we've got our X's and Y test. And then, because the internet is a beautiful place, in 5 lines of code, we can set up and run a linear regression. And that is all that cell does. And so one of the things that you might do is start by taking a look at your coefficients. So one of the nice things about linear regression is that you get back coefficients that are usually pretty understandable. And these ones I think these are pretty curious. So these are fitted coefficients, and for some reason it is just hugely picking up on the percentage of population that's age 65 and above. That for me is a really counterintuitive result. That doesn't feel right to me. And so so as someone pointed out earlier, we did this wrong, right? And so when you get to this point and you get something that makes you go, like make this face, like that should trigger things for you, right? Like this should be the point at which you're like, I bet I didn't regularize my features, for example, or I bet that like there is some like, or I didn't standardize my features. I need to add like a regularization parameter. I have too many variables in here. Like this is kind of weird. And so maybe this is true. Maybe the percentage of population age 65 and above is like the deciding factor in how easy it is to start a business in some country, because it's correlated with some underlying information about, like the retirees aren't letting us start businesses. I don't know. So that's part of the reason I like to start with linear regression, is that you get back results that you can like think about properly and like decide if like, does this make sense? Is this what I thought it would be? And sometimes it's not, right? Like that's part of the reason you do this, is that if you already knew the answer, you wouldn't need to build a model. But if something just feels totally wrong to you, right? Like this is your sign when you like go back and think about it a little more. So that's sort of the message of linear regression. The other thing that I want to talk about is just looking at your model errors. So my 2 favorite ways to do this are by making plots and by looking at my error metric. What we're doing in this plot is on the x-axis, we're plotting what the answer actually is. And on the y-axis, we're plotting what our model predicted the answer should be. In a perfect world, if I am excellent at modeling, everything lies along that orange line. What I predicted is what it actually is. You can see that we do not live in a perfect world, or rather, I do not live in a perfect world. And so some of our lines are, some of our dots are sort of like matching up to this orange line, but many of them are not. And so on the left, we have our training set. On the right, we have our test set. It's important to look at both. So on the right, remember, this is the stuff that our model has never seen before. So in some sense, the plot on the right is the one you care about more. Although the plot on the left is really good for diagnosing what's going on with your model, debugging. So like up here, you can see that actually we're really systematically falling off at the high end. So we're having trouble predicting up at this high end. So you think like, well, maybe I should go back to my linear model and do better feature engineering and feature selection. Oh, sorry, one more thing. So yeah, we're looking here at our mean squared error. You'll see this is a number that makes sense to you in context usually. And you'll see that it's higher for our test set than our training set. I hope that is an intuitive result as to why this is a completely expected result, that the error on our test set is higher. This is the data our model has never seen, and so it wasn't able to cheat by having like peeked into this data already. So if we've done our job well, we have this nice baseline. And now we get to start iterating and improving and experimenting with our model. So one really easy way to start is by trying a different technique. So one sort of workhorse of the ML world is something tree-based. So this is a random forest. Sorry, yeah.
I'm seeing in your screen, your root mean square error for test set is 34, but in my computer it's 31. Why is that?
Yes, that is because when we did that train test split, all of us have a different random seed.
Okay, fine, makes sense.
Yeah, so my apologies. If I had been thinking, I would have set this as or I would have set the random seed, so we all got exactly the same answer. So indeed, do not be surprised if your answers do not exactly match mine. So a random forest is different from a linear regression in a lot of ways. One being that it's nonlinear, the other being that it's tree-based, which means that you don't get back those really nice coefficients that are super interpretable. But what you do get back is a feature importance. And for our purposes, we can think of it as being kind of like a coefficient in that it gives us a sense of what the model thinks the most important underlying variables are. And here, when we're predicting a startup cost, we get things like the startup time in days, the ease of doing business. In fact, the percentage of population age 65 and above is still a factor, but it's not the overwhelming one. GNI per capita. And this to me I like actually. This to me says like, okay, these are things that I expect to matter when calculating the cost of starting up a business. And indeed, if we look at our model error, what we should see is that it does better. We see that it certainly does better on the test set, or sorry, on the training set. Hard to say actually whether it does well on the test set. So in this case, we see that this number for our training set drops a lot, but it actually only marginally improves on our test set. So this is in extreme cases sort of a smell test for overfitting. One of the things that is pretty common is that as you're iterating, if at some point, and this is dangerous because you're essentially fitting on your test data. If let's say you have 50 ML models you want to try, and then you try the test set on all of them, you're effectively turning that into a validation set, and you're actually tuning yourself to that holdout set without realizing it. So you do have to be a little careful about this kind of thing. But in general, if you find that something improves the error on both your train and your test set, that's a good thing. That means you're moving in the right direction. If it improves the error on your training set without improving it on your test set, it's usually a sign that you're just overfitting.
If you change the seed every time between the train and the test set, but you still do it 50 times for different models, then will it be a valid result?
So when I say you do something 50 times, I don't mean the same technique 50 times. I'm talking more about if you have if you're changing something in the model like parameters, or you're changing models every time, you're sort of implicitly biasing yourself you're implicitly biasing yourself towards your test set. Yeah.
Will you ever redo the test set and validation set as a part of your process, just to see if with a different set, slightly different set of data, you would get something very different?
Yes. Yeah, absolutely. We do that a lot and with regularity. Particularly for our in-production systems. The other thing that I often do is stratified sampling. So let's say that I'm sampling from a data set that has some distribution. And in fact, I'm very rarely working with some nice Gaussian distribution. I'm usually working with something that's really skewed. If I sample randomly from that distribution, I'm going to get a lot of stuff in the tail. And so my test set is probably actually not going to be reflective necessarily of what the training data, you can get a mismatch between those two distributions. And so sampling in a way that you're sure that you're getting sort of the same distribution of data in both of those is really important. And that's something that we do as well.
So you're doing cross-validation using the data set?
Yeah, we do a lot of cross-validation as well. I'm not going to cover that here, but yeah, that's a fairly standard thing that most of us will end up doing.
Once we've created your model, how do you scale that to Netflix production?
Yeah, it's in this case, like I have everything in a Jupyter notebook. Internally, we have a lot of tools that allow us to take Python scripts and schedule them on our internal job scheduler. And then we mostly use like AWS to like host APIs and things like that. So then it's a process of like, I mean, this, and actually we also have some tools where you can actually just host a notebook and have it run a notebook too. But there are internal tools that we use for getting things into production. That's actually the end of the tutorial, which I did not expect to get to. So, well done, you guys. Any questions about this or otherwise?
So what is the perfect model for this?
Oh, there isn't. This is real data. It's messy. I mean, it depends on your use case.
What changes do you make to this notebook to make it more productionizable? Like, what sort of functions do you write for pre-processing? Do you write pipelines to add them all up together?
Yeah. So for most of my code, I try to separate the data processing part of it from the model training part of it. So if I were going to put something into production and it was just sort of like a big, long, like Jupyter notebook or something like this, I'd probably start by creating a script that mostly deals with data, and hopefully leveraging some of our internal libraries to make that nice and to conform to things that already exist, make it really readable. Because I am self-taught as a programmer, my first instinct is mostly to write really programmatic code, like just very, very much read top to bottom. But then of course I have to like flip that object-oriented switch often to think about like, okay, now that this is code that other people are going to want to use, like, does this need to be made into a class? Do we need to think about modularizing this? Are there bits of this that are repeated or repeatable? Are there bits of this that other people are going to want to use? So should I just pull them out and just put them into one of our common libraries? That kind of thing. So there's that part of thinking about it. And then for the ML part itself, usually there's not a lot of optimization to be done in terms of like timing and latency on the algorithms themselves, because they're mostly imported and used as is. And frankly, they're mostly pretty optimized by the writers of them. Where a lot of my optimization comes in is in feature engineering. So it's entirely possible that I've written some piece of code for feature engineering that does something in a slow way. Like I wrote a loop when I could have done, like something more Pythonic, right? That just, iterates over the list in one statement or something like this. And so trying to catch those places where it's really going to slow down is something else I think about.
I know you said this is your first job, and
well, it's my first data science job. My first job was, as a cashier.
yeah. your first data science job, and with the data scientists rather than the engineers, because I'm a developer and a data engineer, but I've done this sort of work, and I do believe there's like a time limit. I don't see you doing this until you're 60, because there is a set process with which you do. There's a set amount of tools, and the real skill is being very good at interpretation and communication and team building rather than a lot of the technical stuff. But I don't see anyone being able to do it for 40 years without getting bored and stiff. What is the career progress? Because as an engineer, I could go, oh God, I can work on Netflix. I can work on like machine learning recommendation engines. I can do their QAing, pipeline. There's a lot of many different aspects.
Yeah.
But for doing this and being in this silo, where can you see yourself in 10, 20, 30 years?
Man, but having my mother in the corner over here. No babies, I don't know. It's a totally, completely legitimate question. So my guess is that if anyone's still doing this in 40 years, we all have a problem because the field has not progressed. So I always struggle with this question because 5 years ago, I had no idea I'd be doing this. I thought I was going to be a physics professor. So 5 years from now, who knows? Maybe I'm going to be like playing the accordion in the circus. But unlikely. But so I think that's an answer that's going to be really personal for everyone. So, and it's a question of where do you derive your job satisfaction? My job satisfaction comes mainly from two things, and they're specific to me. One is the feeling that I personally am learning and growing, and the other is the feeling of mastery. I really enjoy personally that feeling of like, there was something I didn't know how to do, and not only did I learn how to do it, now I feel as though I'm capable of like teaching it to someone else, or like it's become mine. It's internalized to me now. Those are the things that keep me going, and those are the things that make my job fun to me. One of the really great things that has happened as a result of data science exploding is also that the domain space and the problem space has exploded. So we're thinking about applying machine learning and data science to fields that 10 years ago, I think no one would have imagined. And so my own personal skill set has changed really dramatically since I started. So I think I mentioned that I didn't know how to write an API when I started. Now I do, right? And that now I know a lot about microservices that I didn't know. I didn't know anything, really about neural networks when I started. And now there's something that's in my toolkit, and I'm working on an NLP project that is, introducing me to brand new corners of machine learning where really wild and awesome things happen under the hood that I just didn't know about 4 years ago. And so for me, as long as this job continues to give me opportunities to continue diving into new techniques and into new projects and into new fields, I think I'm happy there. I like that kind of work. Although I think that the question of when do you become a manager, if that's something you want, is a very real question. I know most managers of people and particularly of people, maybe not so much people who are managing technical projects, but I think most of them will tell you that within 2 or 3 years, their technical skills more or less degrade away to nothing. And so you have to be really sure that that is something you really like doing, because I think once you take that leap, it's much harder to get back into that IC role because the field will have moved on while you were managing.
But at Netflix, could you say to your manager, I want to spend 3 months interning at the chaos engineering side of things, completely different to what you do, and you could potentially therefore move into engineering if you wanted to because they do that here? Is that the sort of thing that is possible?
No, nothing is impossible. I think the question would be, let's talk about why and when the time is right. It's not something someone is ever going to categorically say yes or no to. That's not our culture. It's going to be a question of of judgment. Is this the right time for you to be doing something like that? Are you going to be the right person for something like that? Or is that team frankly going to be better off hiring someone who maybe already knows how to do that job? But I think you see people kind of switching around a fair amount, particularly if they're a little cross-functional to begin with. So if someone kind of already straddles that divide between data science and data engineer, I've seen people switch back and forth between those teams, for example. If I decided tomorrow, I would like to be an expert in marketing because we do marketing here, that's not going to fly because it's going to take me years and years to get to the level of the people that we hire who are already experts in that, right? So I think yes, with qualifications is the answer to that.
I'm curious to know, so learning machine learning or data science, you can take a course on that in Coursera. How do you learn the soft skills on the business part that is related to being a data scientist?
I have two recommendations or two thoughts on that. One is that it's experience, and something that that's really helped with feedback. We're a feedback culture here, and that sounds scary, but it isn't. What it does mean is that when there are times that my soft skills are lacking or could be better, someone is free and probably will tell me. And they don't mean it in a harsh way. They mean it to make me better, which is great. For example, and I'm sure you've picked up on this, when I speak publicly, I have a terrible habit of umming. And it's gotten better since I've worked at Netflix, but someone actually said, hey, I noticed when you speak publicly, you have a nervous tick. You say all the time. It's something you should work on. And I was like, oh, great, that's really good information. You should call me on it when I do it, and I'll try and focus on that. Or, if you mishandle something, or if you handle something well, someone will tell you like, hey, you did a great job like handling all of those teams. Like, I didn't know you had that in you. That's amazing. So there's that aspect of it. It's just practice and getting good and honest feedback from people who are going to tell you the truth, but in a way that they mean it to help you, not to cut you down. The other aspect of it is maybe, I don't know if this is what you meant, but just in terms of like, if you're in a different field, or like in my case, I was in academia. And so I just didn't have a lot of that core business knowledge to begin with. I just read like 4 or 5 books on startups. So I read Lean Analytics, I read Lean Startup, I read, they all have titles like that too. They're like all the same. But like just to get a lot of the jargon down, if someone comes in and they're talking about like their KPIs and their CAC and like all of this, and you're like, I have no idea what that is, so like knowing that like, oh, you're talking about a customer acquisition cost, or when you're talking about churn, you're not talking about butter, you're talking about, like the number of people you lose every month, right? So just like, some of it is just like read books in the field to get an understanding of the kinds of metrics they're thinking about, the kinds of problems they're trying to solve, and the jargon that they're using.
For like machine learning or deep learning, for example, like computer vision, there is a place called Kaggle that we can get experience. So when we get hired, the experience is quite important to get the factor of knowing the candidates, right? But for like any general the machine learning project other than computer vision, do you have any recommendation for us to experience or have some sort of hands-on project?
Yeah, the question, if I understand you correctly, is outside of Kaggle, what else can you?
Yeah, outside of computer vision.
Yeah, my suggestion is, and I'm not a hiring manager, to be honest, so this is all to be taken with a grain of salt. I think it is helpful to have a project that showcases as much of that data science arc as we talked about as possible. So not just what your leader number is on a Kaggle board, but like how you thought about that whole project, and make that publicly available somehow, whether it's through a GitHub repo or through a personal website or something like that, so that you have something to talk about in interviews, you have something to put on a resume that someone can go and check out and see how you think. And in terms of like what that project would be, my advice there is honestly to do something that you're really, really interested in. One thing I think can't be faked is, maybe it can, but if you can, more power to you. But like, one thing I think it's hard to fake is passion. So like, I still to this day think that part of the reason I got this job is that for me, like, I am a huge movie buff. I love the entertainment industry. I walked into that interview with the feeling that like, this is my job. This is the job that like, this is like, I want to be here, and people they want volunteers, not recruits, right? Like they want you to want to be there, right? And so anything that you can talk about that displays that real honest like thing that makes you happy and lights you up, I think is going to be helpful to you, because that's what you're looking for. I think is you're looking for someone who's excited to be there. Like, I mean, I personally don't want to work with someone day in and day out who's like, about everything, right? Like, so yeah, I think in terms of like what to pick, like pick the thing that your nephew or somebody is like, okay, Aunt Becky, enough about that already. Like, okay, stop talking, like pick that thing. Annoy small children with it.
I have a question about how much of your day-to-day work is helped with like platform teams versus how much of like the problems or like, like the problems that occur often, like you're still kind of on your own for like solving like a long-term solution for it?
So most of the data engineering stuff that I rely on is handled by a platform team. So if my data pipeline is broken because like there's some upstream problem, that falls squarely in their camp rather than in mine. And then essentially any code I've written myself, again, unless the platform that is supporting it has gone down, I consider that to be like sort of my area of responsibility. Does that answer it?
Yeah, I guess I was also asking more about like tooling, like for example, like you have the hosted notebooks that you can collaborate, like things that like if a team didn't exist to like support that, like you would have to figure out with your own team how to collaborate with notebooks, like that kind of.
Yeah, so we're super spoiled. We have amazing internal platform teams that like build us all kinds of crazy cool tools to use. I think on our own, we would figure it out. Like I, for example, am a really big fan of like the knowledge repo that I think it was Airbnb that released. I think that's a super cool platform, super cool idea. They've open sourced it. So like we would figure it all out, or we would purchase tools that exist now to do all of these things. But luckily for us, we do have an awesome internal team that builds a lot of really cool stuff I use.
Does Netflix create their own algorithms too? Because
Create their own.
create your own algorithms for optimization and prediction?
Mostly not, at least not with my team. We do have folks that are working on different problems that I think are innovating more in algorithms in that space, but I can't speak to that.
Oh, so do you think it's a bit of a risk because anybody who gets hold of your data can use any of the algorithms, like there are only n number of algorithms in the machine learning space, and use them and get their own predictions and kind of, do the same thing as you.
Well, if they had the same richness of data, yes, they could. But our data is completely internal. It's not something we release into the world, so that is not that's not really a concern for us. Most of these techniques are they're not proprietary, right? Like anyone can write their own gradient boosted decision tree in their own code. So there's nothing secret about that part of it in particular.
Do you open source any of your stuff? Do you work on algorithms and different models and creating something rather than like using all of the random forest and everything built in? Have you done anything sort of internally specific and then contributed it to open source?
There are Netflix has open sourced lots of projects over the years. My team in particular has not open sourced something, but we're still kind of nascent. So I think that it's not out of the question. It's just not something that has happened thus far.
How much of time do you spend in cleaning up your data? Like I see a lot of plans and you basically substitute it with means or your way of doing it. Do you really have to do that or do you get the data cleaned up pretty by the time it comes to you in general at your job?
It is it's a negotiation. I think like our data engineers are getting data to a point where their goal is to get the data to a point where it's self-serve for all the various teams at Netflix. So they don't necessarily want to write tables that are specific to me, Becky Tucker. They want to write tables that like everyone in science and analytics can use. And so that means that they're often writing sort of a more generic table than I specifically need for my model. So in terms of a lot of the data cleaning, like all the data cleaning that happens up until that point, that's definitely on them. A lot of what I end up doing is not so much the cleaning with like the nans and things, but it's figuring out, okay, given all of these tables and this data that's available at Netflix from all these different sources, I need to figure out how to pull that and get that into a structure I need for this very specific problem.
Following on that, let's say in the data exploration phase of data engineering, they probably will remove certain columns or things like that, which didn't make sense for them. when it creates your data things, really good. And did you ever end up going back to your actual source of data to figure out, maybe because it probably missed it or probably didn't see the correlation which you would have seen? Did that kind of thing happen where you kind of have to go back to the home start point rather than going back to?
It's never happened to me, but I think even if it did, it would not be a big deal because why would it be? So like you go to them and you say like, hey, I need this column, and I think it got dropped, up here, and they would say, great, we'll add it back in.
So you do have an idea of the entire data set, what the raw data set?
In some cases, yes. In some cases, no. It depends on where it comes from. It's domain specific. So there's some data that I'm just much more familiar with than other data in our company. So if I was using data that I wasn't super familiar with, so for example, our streaming team has a lot of data about Open Connect servers and stuff like this that I am just not familiar with. So that's a case where I wouldn't know. But anything on the content side, I know that ecosystem well enough to have that conversation more.
Do you choose more than one model to run in production?
Sorry?
More than one model to run in production?
Oh yeah, usually. There are often it's not more than one model usually because we couldn't decide between them or anything like that. It's usually just more that the problem is complicated enough that you want dedicated models for specific use cases, even though it's kind of all under the same umbrella.
I have one quick question. I'm curious to know what's the review cycle like for a data scientist? For example, for engineers, so 2 engineers have to review your code before it goes into production. What's it like for a data scientist?
Well, again, we're not big on process. So if I wanted to, I could push code to production without a code review. That would be probably not great judgment on my part, so I wouldn't do that. But there is no standardized code review at Netflix, really. But it's a matter of judgment, how big is the change that you're planning to make, and who is the person that's sort of most up to speed to help understand it. And so my personal process is that I work on a team of 4. And if it's a super minor change and it's just a quick thing, I always submit the pull request. So that people have record of it and have record of what I've changed, but I might not necessarily set up a full meeting to do a full code review with someone for a 1-line change. For bigger changes, then it'll probably I've had as many as sort of 3 back and forths on we did the code review, there were things to change, we did a second code review, there were things to change, third code review, and then I pushed. So it depends on the size of the changes and the complexity. All right, we are past 8, so 3 more questions maybe, and then we'll let you go.
I was outside when I was mentioning recording and maybe how we get to your slides, if you would share your presentation. And also the previous 2.
So I think the slides and everything will be available in that same GitHub link.
Yeah, the GitHub has the slides and the recordings upload, and then I'm sending a follow now. Along with the survey again, and some more information. Yeah.
Cool. Thank you very much. I meant to give people in the slide.
Walked around and I said, or be Tucker.
Okay. Thank you.
Hey, I'm sorry. Yeah, Becky. I missed the first half of it.
All right.
And I looked at your LinkedIn profile and I noticed you went.
I did.
Yeah, so I did insight.
Awesome. How'd it go?
Awesome. Yeah, I did the data engineering.
Very cool.
Yeah, and I think that one person who already took my session as my pointers.
Oh, awesome. Yeah, Netflix has
I know, yeah, it has a
Yeah, I think it's just a matter of the just network built up more for data scientists. Yeah, absolutely.
Thank you.
Yes, I totally meant to throw up my my LinkedIn thing. It's in the slides as well. Yes. Yeah. Yeah. So I think that the ones to have in your tool belt are linear languages. And then I think you'll have a lot of success sort of straight out of the box with tree-based languages. So that would be random forest. And then either gradient boosted regressor.
That's the main thing.
Kind of your like
Опять же, за те же деньги они даже не поднимают. Потому что они еще деньги. Они старых продлевают. Да. Получаешь, то я не знаю, как какие да, да.
Yeah, we'll keep in touch. Yeah, there you go. Thank you. All for you. If I could. Yeah, I think too. That's mine. I would have remembered it. Slides, we go up. Everything is on there. Same link that I'm using off.
most because they are very happy.
Yeah, that's all.
So it's
So I feel like that
I mean,
anyway, what Star Wars like.
I would say, so I think
What do you do?
realistically that the data science jobs probably won't get a call back on. But what I would maybe advise you to do is what we call our engineers. As particularly at Netflix, our analysts do
Very cool.
and it's a like essentially also some people with engineering background. I think that that would probably start and you get like analytics. And it'd be a good way to collaborate.